All right, let's get into it. Today, we are going to crack the code on all those AI buzzwords you hear everywhere. We're going to make sense of it all. If you've ever felt like your head is spinning with all these terms, AI, machine learning, deep learning, LLMs, hey, you are not alone. It's kind of designed to be confusing, right? But that's exactly what we're going to fix today. We are going to build a super simple map just to see how all these incredible ideas actually fit together. And by the end of this, I promise you'll see the whole picture crystal clear. Okay, so where do we even begin? Well, we have to start with the biggest idea of all, the giant umbrella that covers everything else, artificial intelligence. So what is AI really? At its heart, it's this huge area of computer science. And the whole goal, the big dream, is to get machines to do things that, normally require a human brain. Things like learning from experience, solving tricky problems, or even just understanding what they see. Now, it's really important to get this next part straight because it separates the science from the science fiction. Right now, today, every single piece of AI you've ever used, your phone's assistant, facial recognition, all of it, is what we call narrow AI. It's a genius at one specific thing. The other two, general AI and super AI, that's the stuff of movies. For now, they don't actually exist yet. So if AI is this giant universe, what's the engine making it all run? What makes it smart? Well, that brings us to our next layer, machine learning. Okay, this slide is absolutely key to understanding everything. For decades, with traditional programming, we had to handcraft every single rule. If this happens, then do that. But machine learning completely flips that on its head. Instead, we give the computer a ton of examples. Here's the data, and here are the right answers. And we tell it, you figure out the rules. It's a total game changer. And it turns out there are a few different ways machines can learn. Supervised learning is like studying with flashcards. You show it a million pictures labeled cat, and eventually it learns what a cat looks like. Unsupervised learning is more like detective work. You just dump a bunch of data and ask it to find any interesting patterns. And then there's reinforcement learning, which is basically trial and error. Think of it like teaching an AI to play a video game by giving it points for good moves. Okay, we're going another level deeper now. Inside the world of machine learning, there is one particular technique that is behind almost all of the incredible breakthroughs we're seeing today. And that technique is called deep learning. So what's its secret? Well, it uses something called an artificial neural network, which is, and this is so cool, literally inspired by the way the neurons in our own brains are connected. It creates a sort of digital brain. So how does this digital brain work? Well, basically, you feed it data through an input layer. Then that data passes through these hidden layers in the middle. This is where all the heavy lifting happens, the pattern recognition. And the deep in deep learning, it just means there's more than one of these hidden layers. Finally, you get your answer from the output layer. To make that a little less abstract, let's use a silly example. Imagine you're trying to decide, should I order pizza tonight? A simple network could take in a few factors, right? Like, do I have a coupon? Or am I feeling lazy? It would weigh those factors and then spit out a yes or no. Deep learning is just doing that on a massively more complex scale. And yeah, it's not just for pizza. This is the magic behind how a self-driving car can instantly tell the difference between a person and a traffic cone. It's how your phone knows it's you and not your friend. It's amazing at making sense of really messy real-world data, like images and sounds. All right, so we've got our foundation, AI, machine learning, deep learning. Now let's talk about the crazy stuff that's all over the news right now. This is the cutting edge. First up, you have to understand this idea of foundation models. This has totally changed the game. Instead of building a custom AI for every little thing, researchers started thinking, what if we just trained one gigantic model on like a huge chunk of the entire internet? And that's the big shift. We've gone from building one-off, specialized tools to creating this massive, powerful base model that can then be easily adapted for all sorts of different tasks. It saves a mind-boggling amount of time and work. But, and this is a really big but, there's a major trade-off. The good news? These models are incredibly powerful, and they make developers way more productive. The bad news? They cost a fortune to train and run, and even more importantly, because they learn from the wild, unfiltered internet, they can learn all of our biases and a whole lot of nonsense, which makes trusting their output a real challenge. So you have these giant foundation models that have learned all this stuff. what can you actually do with them? Well, you can get them to be creative. And that's what generative AI is. It's the application of these models to actually create brand new things, things that have never existed before. And this is where you've seen all the amazing demos, right? Large language models, or LLMs, can write an email or a poem. Vision models can create a beautiful image just from you describing it. There are even models that write computer code or compose original music. They are generating new content based on the patterns they learned. Okay, deep breath. Let's zoom back out now and put all the pieces of our map together so you can see the whole picture. So here it is, the whole shebang. It all starts with the giant universe of artificial intelligence. Inside of that, you have the engine, machine learning. A really powerful type of that engine is the digital brain of deep learning. And riding on the very tip of that spear are the foundation and generative models that create amazing new things. So, if you remember one thing, remember this. These terms aren't fighting each other, they're building on top of each other. The best way to think about it is like those Russian nesting dolls. Each one fits neatly inside the other, creating something more and more powerful as you go. And there you have it. You just got a complete map of the entire AI landscape, from the biggest, oldest ideas to the stuff that's literally being invented as we speak. So now you've got the map. You know how all the pieces fit together, which leaves just one big question, right? Where do you think this is all going? What's the next layer of the onion going to be? That's something to chew on.